Students, this question was asked from chapter 5 of class 11, that is from the chapter of work, energy and power. The question tells that a ball moving with velocity 2 meter per second collides head-on with another stationary ball of double the mass. If the coefficient of restitution is 0.5, then their velocities in meter per second after collision will be how much among the given four options. The question was asked in the year 2010. This question was asked in the year 2010. So there are two balls. Okay, student. One ball is moving with velocity 2 meter per second. Another one is stationary 0. So U1 is 2 meter per second and U2 is 0. And the mass of the second ball is double the mass of the first ball. Suppose the mass, let its mass be m and its mass be then twice m. Okay, student. Then what will be the principle of conservation of linear momentum applied to this situation, student? Then the sum of the linear momenta of the system of particles before the collision must be equal to the sum of the linear momenta of the particles after the collision. So m1 u1 plus m2 u2 should be equal to m1 v1 plus m2 v2. Okay, students. Then what is here m1? m1 is m. We have taken m1 as m. And what is u1? u1 is 2 meter per second. So we may write 2m. And what is m2? m2 u2 is 0. Initial velocity of the it was stationary, so it is 0. So this term is 0. Okay, student. Then this will be equal to how much? m1 v1. m1 is we have taken m, and what is v1? v1 we have to find out. v1 we have to find out, and this is m2. m2 is equal to student twice m. So let us write here twice m, and this is v2. v2 also we do not know. So if we cancel this m from all the divide this equation by m throughout in the left hand side and right hand side, we get an equation 2 is equal to v1 plus 2 v2. This may be equation 1. Okay, student? Then the coefficient of restitution is given 0.5. What is coefficient of restitution, student? The coefficient of restitution or the coefficient of resilience, that is denoted as E, and this is the ratio of the relative velocities of the bodies before the collision and after the collision. So this is E is equal to minus E is equal to actually v2 minus v1 by u2 minus u1. Okay, students. So this implies that 0.5 means half. So minus half is equal to v2 minus v1 by u2 minus u1. u2 what is u2? u2 is the initial velocity of the second mass. It was 0 because the body was stationary. And what is u1? u1 is given there, student, 2 meter per second. So we may write this as this is minus 2, 0 minus 2 0 minus 2 multiplied here. So this is minus 2 by 2, that is plus 1. Or we may write v2 minus v1 is equal to 1. This is our equation 2. And we had already one equation, v1 plus 2 v2 is equal to 2. Let us write here below v1 plus 2 v2 is equal to 2. This was our equation 1. So if we add these two equations, student, v1 cancels and 3v2 becomes 3. So implies v2 is equal to 1, student, that is 1 meter per second. And what will be v1 from this equation? v1 will be equal to v2 minus 1, or 1 minus 1 will be equal to 0. So the final velocity of the first body will be equal to 0 meter per second, and the second body will be equal to 1 meter per second. So 0, 1 will be the answer. Where is it? It is in option A. So students, option A will be correct for this question.